Hi, I'm Anne. I will be a senior in IOE department in the fall.
I'm Christine, and I will be a junior in the fall in IOE.
I'm Luo Chen. I will also be a senior in fall. And our topic is the hand exertion and kinematic constraints. And our faculty advisor is Monica Jones and Mary Reed. First of all, let me say something about our research. Our research looks at how people support themselves by exerting forces with their hands. And this is measured by placing our subjects under different kinematic constraints. Now let's look at how our laboratory configurations are. And the whole setup mainly consists of 5 parts. The first place at the ground, and the bracing hand support, and the external bracing support, which we also call the die board, and the task handle, and force feedback display. Our subjects are required to exert a force in a certain direction to the task handle, and our subjects can see how much forces they use from the force feedback display so that they can control themselves to keep their forces steady to pass our test. And they can choose either to use the bracing hand support, which they put the opposite hand, which is the left hand, on it, and they can also choose to put their die against the die board. Here is a real picture showing how our subject looks like. And can you see these little markers? These little markers on her back and shoulder and etc., mainly on joints, are extremely important in our experiments. We have 8 cameras surround the whole setup, which we call the motion captures. They are used to catch the light reflected by these reflective markers, so that we can know the position of our subject. And let me talk about our data collection. Altogether, 25 subjects participated in our experiment. Among them, 12 are females and 13 are males. And totally 4,256 experimental trials and 625 balance trials are collected. This is a huge number. And we collected 30 channels of analog data, which includes the forces and moments at the task handle, the hand bracing surface, and die board, and also we collect the forces made by the subject's feet. And 33 markers are put on our subjects. These are mainly put on joint angles, which are shoulder, elbow, wrist, ankles, and etc. And we also put markers on the structure so that we can know their position very precisely. Now let Anne talk about something about details.
First of all, the task handle can be adjusted vertically at 3 different heights: the sternum height, pelvis height, and mid-thigh height. And it can also be adjusted horizontally at a far distance, which the subject had to lean forward, or it is close to the subject. And the bracing can be adjusted horizontally too, whether near or far from the body. And it can be also adjusted parallel to the task handle or orthogonal to the task handle. And there are 5 force direction. The subject can push forward, pull backward, lift upwards, exert right or exert left. And the force magnitude exerted are whether at maximum or 50% at the maximum. And the subject can exert force without any constraints available, or exert force with only the opposite hand. The third condition is the subject can exert force using only the die board, or the subject can exert force with all surfaces available for him or her. And here are some pictures taken. The first column, the subject push forward, and the second column is pulling backward, and the third column is lift upward. And from the first row, you can see the task handle is near to the body. This is at the proximal distance. And the last 2 rows are far distance. And you can see the last row, the bracing support is orthogonal to the task handle. And the first 2 rows, the task handle is parallel with the bracing breathing support. And now let's hand over to Christine.
And I'll talk about some of what we're doing currently right now. The data processing. Since the data is collected by motion capture cameras, all that registers in the data that we get are the body trackers. And so our job is to make sense of this, and we do so by loading it into a motion capture or into a software that reads motion capture data, and we label all of the body trackers. In addition to labeling, we are also in charge of differentiating between the correct body markers and the noise that gets picked up along with other reflective surfaces that may have been caught during the trials. We are to do so during each of the trials and all of the every motion that the subject goes through. We label such things as you can see in the slide: the head, the wrist, the hips, and the knees. And these are all labeled via a template that we have calibrated according to each subject's body measurements and anthropometry. These are then to ensure that they correctly pick up on all of the body markers of the subjects, since everyone has a different range of motion or measurement in their body measurement and how they react to the different configurations that we give them. So that here's another view of it towards the side, which is when they are in their standing posture or in their holding posture in the last 3 seconds, which is most important. And we do this so that we can simulate correctly the motions of each subject that we collected. And as Lochen mentioned earlier before, there are over 4,000 trials that we are dealing with. So that is currently what we are working on right now. But as in the program in general of SURE, we have gained a few benefits from it. We've learned valuable lab experience. We got to work in a real engineering lab, which ours is the HumoSim lab. We've also got a chance to network with other faculty and research students that are, in addition to our department, also in other departments as well. We also learned new technical skills. For example, we all learned how to use the Vicon software, which we had never used before, and we also got a preview of graduate students' work in case we have. So now we have an option of looking into graduate school maybe after we finish our undergrad. And so all in all, this was a good experience and a great opportunity.